Hello everyone, welcome. In this talk, I'm going to give you a very simple example so that you can translate or understand what machine learning is and how it works. Let me just give you one quote from one of the front runners in the field. AI is the new electricity. Just as electricity transformed almost everything 100 years ago, today I actually have a hard time thinking of an industry that I don't think AI will transform in the next several years. Let's see our example. Let's say the problem is building ML model to classify images as dogs or cats. Okay, so we want to build machine learning model that can be able to classify images. So we show the image of dogs and cats. So let's translate this one into a basic analogy example. So this is the same as teaching babies and selecting the best one. So what does it mean? So you have multiple babies or many babies, and then you want to teach them how to identify dog image from that of the cat image. And then at the end of the day, you want to teach all of them, but you select the best one. So let's say, for example, we have 2 babies. In this example, it may be 10, it will be 20 or 100 or whatever number is. But in this simple example, I'm going to give you that we have 2 babies. So the data that we need is, so what do we need at the beginning? We need to collect image so that we need to show the image, the image to the babies, because we need to teach images of cats and dogs, right? So let's say, for example, we collected from the web, we downloaded images of dogs, 50 images of cats, 50, a total of 100 images. So we want to use these images for teaching the babies. The first step that we need to do is split this 100 images into 3 sets. Forget about the machine learning concept now. Split randomly. This 100 images, 80% will be in set 1, 10% will be in set 2, and the other 10% will be in set 3. So we have 3 sets, 80, 10, and we start with set 1. We have 80 images. So in these 80 images, when teaching the babies, so our purpose is to teach the babies, right? They don't know how to identify images of dogs and cats, but we want to teach them. We show them both image and levels. This is just like tell them that this is a cat or this is a dog. Let's say that this is an image, and then we want to teach to baby A. So we show the image, and then we tell him that this is a cat. As a next step, we show another image from those 80 images, and then we say that this is a dog. We tell him and show him. And then next is for a cat. This is the cat image. This is also a cat. So we go for 80 images. The same thing for baby B. We have another baby. We want also to teach that baby what or how to identify those images. So we have the image, and also we tell him that this image is a cat. This is the same thing. This is also a dog. So we go for those 80 images. So what we're doing here in set 1 is that we show the image to each of the babies, and then we tell them that what this each of the image is, because we're giving the image, and at the same time, this is what it is. So based on that, we teach them. So it means that at the end of the day, both babies will learn something. We learn how to identify or categorize the image. So we take the second set, which is set 2, having 10 images, but at this time, we only show them the image. We don't have to tell them what the images are. It's their task to categorize what these images are. So let's say, for example, we show the first one, but we don't tell him what this image is. So his task will be just like to tell us whether this is a dog or a cat. The next one, another image, but we don't tell him the image, what the image is, and so on and so forth. So these are for all the 10 images. So we give him a test to the first baby for set 2. So we show them we show him all the image in set 2. So at last, once we just show him, and then he will tell us what this category are, and then we take the accuracy. So for example, here in this case, 90%, accuracy is 90%. So it means that 90% of the time he correctly identified the image. He made a mistake 10%. So we show the same 10 images for the other image too, for the other baby too. So we show him the image, but we don't tell him what it is. And then his task will be to tell us what it is. And then the next one, and then the next one for the 10 images. And then at last, we take the performance or the accuracy. So in this case, baby B is getting 80% right. In this case, the first baby, baby A, is getting 90%, while baby B is 80%. So baby A is the best one. So once we take baby A from set 2 based on set 2's performance, what do we do next? We take set 3, which is 10 images, and the same thing, we show only the image, but we show only to the best one. We don't have to show to baby B because he's already gone. We select the first baby, and then we show him this using the set 3, another image, which are the 10 images. In set 3, we show him, but we ask him what it is. It lasts for this 10 images, and then we get the performance. So the performance here in this case is 85%. So what does it mean? This is 85% of the time has got it right, but 15% he didn't get it right. So what does it mean? So what we're saying is that we have the best model or the best baby, but this best baby, he performed 85, because in the set 2, even though he has got 90%, but that 90% was only used for comparison with other babies, not just like for the final one. So the final report is 85%. That's the concept of machine learning. Now, let's try to translate this concept into the machine learning concept. So the babies are what? These are the machine learning models. The same as what we're teaching for the babies, we're teaching to the ML models. It's the same. And then the data, we call formally the data as data set, okay? So we have the data set, which is the 100 images. So we have 3 sets, right? Set 1, what did we use for? This one is used for teaching the babies. So we call this one as training set. We are teaching the models, that means. So we call this one as training set. The other one is set 2, which is the validation set. This was used, if you remember that, this was used to compare the baby's performance, right? So this is, we call this one as a validation set to compare that and getting the best model, that means. And then once we have the best model, and then set 3 will be used to get the final performance. So we test to the best baby, which is the best model, and then we get the final performance or accuracy of that model. So the other one is we use also an evaluation metric, which is accuracy, because for example, if we have multiple athletes, then how do we just rank them? How do we know that which is the best? So we have to just like make them run, and then we have the time, the fastest will be the best. The same thing also here, the performance of the babies will be evaluated or was evaluated by the accuracy. So we call this one as evaluation metric. Showing the image and levels to baby. So this is in set 1, which is training set. So we are teaching or training the ML models. And then ranking babies' smartness. So it means that we are comparing the multiple babies after we teach them. So we took the first baby. This is just like we take the best model from all the models trained or taught, that means. And then so we select the best baby. We call this one as model selection, actually. So model selection, model training is for set 1. Once we have the best model, we need to report the final performance, which is the set 3, which is the test set. It's having 85%, that means. So once we have that, that's it. So we have the problem, we define that problem, we collect the data, And then once we collect the data, we split the data into 3 sets. One is for teaching or training. The other one is for comparing multiple ones and getting the best one. And the last one is for getting the performance of the best model that we have. That means that's the concept of machine learning. Every machine problem is just like defining in a similar way. It could be changed in the type of problem, the type of the data set. For example, it could be images, it could be videos, it could be text or numbers, but the concept is the same.